Hey, welcome back to the channel. Got a little something on the bench for you here. So this is the super duper mega ultralight 138G4S 5-inch or V2.2. I'm sorry, that just never gets old. You just add more names to it and it makes it cooler, right? So anyway, in this video I'm going to take the Frsky R-xsr receiver out of this build, and I am going to replace it with the HappyModel EP1 RX. Okay, so gonna get rid of Frsky from this and basically only doing the receiver. So I've flown this, I kind of know this quad, and I feel like, if I replace the receiver and that's all I do to this quad, I'm gonna have a pretty good idea of what the differences are, so that I can kind of give that information as well. Basically are going to pull this quad apart. We're going to replace the receiver. I'm going to grab my radio master and go through the settings on there to make sure they're correct. And then we're going to jump in the Betaflight and change some of the settings in there as well, and get everything, bound up and ready to fly, and then take it for a rip. So that's what this video is going to be about. So stay tuned. So before we get started tearing the things apart, I just kind of want to go through a little something. So this video right here that I did has really kind of made me a little aggravated with Frsky, and it feels kind of good. I've got a buddy of mine that's kind of pushed me into doing ELRS, and I've done it with a Whoop now, and now it's time to do this quadcopter. Frsky, when they came out with their V2 firmware, I kind of knew, like, oh, this is not looking good. The backward compatibility, leaving people behind, all that kind of sort of thing. So that's kind of one of the things. But after flying that, let me grab it. After flying this little Whoop, the Diamond ELRS board, it is absolutely amazing. The difference between the SPI D8 Frsky receiver and the built-in SPI ELRS receiver. I don't know how to explain it, but like, as you're going toward a gate with the Frsky, you got to anticipate and you got to make the movement, and then the quad does the movement. It's just so minute, but when you're moving pretty quick through gates, you do feel the difference. So it just feels like it does exactly what you want it to do when you want it to do it. You don't have to have that anticipation as much. The other thing I notice is the Frsky D8, it would kind of incrementally change. And now it seems to be very fluid. Just so that little bit of, just a little bit. I'm kind of wondering what is it going to do on this thing. So I'm kind of excited about that. So before I go too far into all that, I would like to outfit more of my quads, but this is going to be my kind of test of whether or not I'm going to like this. So the first thing I'm going to do is go ahead and get my props off, take my top plate off. Now I have a full build playlist, so obviously if you follow the channel, you know what this is. If you don't, this V2.2, I did I think it's 8 videos, maybe 9 videos of every single thing on here. And then thanks to Serge at Pyrodrone, in collaboration with him, we gave away one of these frames, and then I took I custom made all the TPU on this, and I gave that away too. I'm thinking about doing that again, or getting something going with that. So if you're interested in, what's up with this build, this is like 236 grams all up with a 4S tattoo R-line. So all up in the air, 236, and this thing absolutely boogies. So I'm going to go ahead and take the props off, take this thing apart, and we're going to go ahead and get started. Alright, so we got everything kind of taken apart here. You can see I've cut the RxsR off. As you know, I took the connector off of that one and soldered it in myself. So these are my wires anyway. So it made it easier because I already have the 3 wires. I do have to remove this one from T2 pad. So I was running my smart audio here, and then I was running my S-bus, power and ground here. So the cool thing is with the LUA EP1 receiver, you only have the 4 pads, and you're only needing to use 1 Uart. So here I have a little diagram. So basically any flight controller, and this is the correct orientation for my quad, these 4 pads right here. So you have ground, 5 volt, and then a full Uart. So you have your RX and your TX pad. So the full Uart. I no longer have to use the T2 pad over here for smart audio and the R1 pad for S-bus. I don't have to do that anymore. Obviously, I could have done F port and just ran the 1 wire to do both things, but I didn't. So we're going to go ahead and get these 4 wires connected up to the receiver, and I'll go ahead and get this out of the package. We'll just kind of look at it, maybe do a couple dimensions. But I need to unsolder the S-bus smart port telemetry wire. I'll unsolder that, and then I'll make a long wire, the same length wire, to the TX1 pad. So now it's time to grab our receiver. They do give you a little piece of shrink tubing to go over the receiver. In my case, I'm not going to do that. I'm going to have it, I have plenty of space in here between the standoffs and the top plate of the VTX. However, I am going to, if you see here on the back, there's components on both sides. So these components here, I don't want them coming in contact with anything. Basically, I'm just going to insulate this side with my favorite is double-sided adhesive. This is Gorilla Tough and Clear, and it's, I think it's 15-pound poster adhesive, and this stuff is just amazing. I can't say enough about it. But I'm going to use a square piece, the size of the back of this, and that's what's going to retain it to my VTX. It's definitely not going to go anywhere. I'll get some measurements of the parts and pieces. So we're looking at 53 millimeters, 98 millimeters. The one I'm going to use is the same, which should be the same, 52, 53. And then from the T-bar to the UFL connector, the end of the UFL connector is 48, 47. We'll say 47. And the component itself, so 10 by 10. With the UFL connector, we'll just do that in case you're trying to squeeze it into something. It's at 5 millimeters. So you're going to need more than 5 millimeters to put that in, because you're also going to have to take into account that, you know, whatever adhesive you're going to use to put it in, or zip tie. So I'm going to go ahead and clean this up real quick. Alright, so the first thing I want to do is I want to put a little bit of flux. This is the flux that I use. I want to basically put just a very small amount on these pads, so that the solder will adhere to these pads quickly without having to use a bunch of heat, and they will come out nice and smooth. You want to definitely have some sort of catalyst between your solder and your, I know that the solder I use has a flux core, but I like to use a little bit extra. Alright, I have my double-sided adhesive on there, and you can see that I just went a little bit further past, so that any exposed wire or solder joint isn't touching anything. So I just basically gave it a little bit of extra to cover the whole thing. The cool thing about this stuff is you can just pull it to one side and it will come off without ripping your components off, and it doesn't leave a residue like the 3M stuff I used to use. So we'll go ahead and put this in the quadcopter. Now, one thing about this adhesive is you don't want to touch it. So anything you do, you want to make sure you're using a tool, because you don't want to touch that adhesive. A little bit of fingerprint oil on that, it loses its stickiness. But as long as you don't touch it and you put it to a surface, I mean, it sticks to carbon. It sticks to everything. It's amazing. So I think that's where I want that. And then this will loop around nice and smooth and zip tie down to my top plate nice and tight. And then, of course, I have the turtle stick to kind of protect the front of that edge of the wire. So it should work out pretty good. And now I'll just bring my wires straight up to it. So I need to pull these out. So I've kind of got an idea where I want that. I'm going to go ahead and twist these up, and then we'll figure out which ones go where. So the ground is straight across from the UFL, and then next to it is 5 volt, and then the TX pad and the RX pad. So the RX is the furthest one from the ground, and the ground is straight down from the UFL. I don't trust anything that I read online, right? So I'm going to grab my multimeter real quick and just make sure of that. So if you're unfamiliar how to do a continuity check, I have a video in my quick tips playlist of how do you do a continuity check, how do you measure a LiPo, all kinds of information in there for you. So basically, the body of a UFL, the outer area, the outer sheathing of the UFL is always ground, or should be ground. So we're just going to touch ground here. And so we know that that is true, that the cheat sheet is correct. This is the ground pad. We shouldn't have any continuity to our 5 volt or our TX or RX pad. So we know that's ground, so we're going to go ahead and wire it up as such. So we're all wired up. Ground to ground, 5 volt to 5 volt, R pad to T pad to R pad. So all the hardware is completed. Okay. All right. So I'll give you this here in case you need to take a screenshot. They don't put any material in the package for you. You have to take a little QR code to get the manual. So the next step we need to do is we need to grab our radio. Let me go ahead and get that now. All right, got my radio on the bench here for you. Got the external module placed in the bay. I have my antenna attached. You want to make sure your antennas are on, because when you power up the internal or external module, you want to make sure the antennas are on so that your modules don't overheat, burn up, or whatever. So go ahead and power up your radio. There's a few things that we need to go through. So if you go to systems, there should be in EdgeTX, it'll be the first option. But if you go to tools and you go to your LUA Script, now to do the Expresslrs, your radio needs to be updated to a certain level. So OpenTX, it needs to be 2.3, 12 or higher, or EdgeTX. The developers of EdgeTX say, or ELRS say to, just update to EdgeTX. So this does have EdgeTX. Now this one was already preloaded with Expresslrs LUA Script. Okay. So if you go to systems and you don't have the LUA Script in tools to be able to go in, let me try to explain the LUA Script. So basically, LUA Script is the firmware needed to be a communication between your radio and your module. So you're able to change settings via your radio. So it's kind of nice. It's kind of like a remote control of the settings and firmware updating of your module. Just those communications. So you need to have that information on your SD card. With that said, I want to show you something real quick. So once you have it downloaded, or it's already preloaded as this one is, The internal module on this one's having all kinds of issues. And Radio Master's sending me a replacement board and module. I'm not sure when I'm going to get it, so that's why I'm using an external module. And this radio already has Expresslrs loaded. So if I go to that, and you see here it says loaded and then white screen, there's nothing happening. Well, there's a reason for that. Even though the firmware is downloaded, our module's not on. You can see there's no LED light. So the issue is, let me get out of here. If I go into this model and you go up here, the external and internal module is turned off. Well, you need to have your model set up, and you need to have either your ELRS internal module or your external module turned on. So let me go out here. Let me grab a model real quick that already has the one we're working on that we all soldered up. So now the module is turned on. You can see that the LEDs are on and it's ready to go. So now I can go to System and I can go to Expresslrs, and it will load the communication between the radio and that external module. So I can change packet rate. I can change all these different variables. TX power, yeah, on and on. And then I can also enable the Wi-Fi communication from the external module. All that stuff is remotely done from this screen. So you need to have the Expresslrs LUA Script loaded onto your radio. Let's say you don't have it. So let me go ahead and back out of here. If you go to Systems and you go to your scripts and then go to Tools, you can see here all the different LUA scripts that are in here. All right. So here's the one that we're going to use. Okay. So you need to load that onto your radio first thing. So let's go ahead and get that done. You want to plug in a USB cable either up here to the USB port and run mass storage, or you take the SD card out of your radio. So you can turn your radio off, pull the SD card out, stick it in the computer, and then put that file on your SD card. In our case, I'm just going to go ahead and plug in a USB cable to the top port here. The bottom port's for charging, and this is for mass storage or joystick for simming. So once I plugged into the computer, I have an option of either going to mass storage or joystick. So that's what we're going to do, is go into USB. So we'll go ahead and leave this sitting here. Turn my screen back off. It'll turn on. Let's go ahead and jump over to the computer. All right, so once we're over here at the computer, as you can see, 2 files have popped up. So this is the internals of our radio, if you will. We don't need this window. And right here, if we go to Scripts, so double click on that and double click on Tools, and in here you'll see that we have our ELRS LUA Script. To get this, we need to go to ELRS. And so in the ELRS, Expresslrs configurator, so you need to find this and download this configurator. And you want to start off, I'm show pre-releases. These are things if you're really knowledgeable about the firmware. Otherwise, just leave that unchecked and just pull up the newest date. And then our target, we're going to be working with the 2.4 gig HappyModel. Let's see if we can find that. So it's alphabetized there, and then the device that we're using is the Pro. So this is the HappyModel ES24TX Pro series external 2.4 gigahertz transmitting module. So that's what we want to use. Now, we don't have to worry about any of this right now. We can go further here to set up a build for firmware updating our external module. So in this case, we just want to download the LUA script for now. So we'll go ahead and click on that. And then in the file, so this is the internals of the SD card through the USB into the radio. So we'll just go to Scripts, and then we'll go to Tools, and then this is where we're going to download this. So we can just save the file here. Obviously, I already have the file needed, so I don't want to do this. So do you want to replace it? No. I'm just going to cancel that. So that will download the LUA script file that you need into your SD card. So we can go ahead and close our file here, and we're done in here. You'll want to just come back and check in here to make sure that it's in your scripts and tools file. So just click on that and go to tools and just make sure that your file has come up as a LUA file. So that should take care of that, and then we can move on. So go ahead and close this, and we'll go ahead and exit and unplug our USB cable. Alright, so we'll just go ahead and unplug our USB cable, and you can power cycle the radio if you need to, but if you go into systems now, you should have Expresslrs. So that should be all taken care of there. The next step that we need to do is prepare our radio. Okay, so let me put this cord out of the way. So we need to make sure, let me page over here to version. So I'm running version 2.6 of EdgeTX. If you're running OpenTX, you need to run 2.3.12 or higher. That's what the information is said. So 2.3.12 or higher for OpenTX, or you need to run EdgeTX. And the other thing we need to do is check a couple other things. So we'll turn out of here. So in systems, we'll go ahead and page over to hardware. So we're in hardware. Go ahead and back up one or a couple. See the ADC filter? We need to make sure that's unchecked. We don't want the ADC filter on. Make sure that that's taken off. And then the internal module is Crossfire and baud rate's 400K, but we're not worried about that. I'm not using the internal module on this. Okay, so that's the only thing we need to do in hardware is just make sure ADC filter is turned off. So let me go ahead and back out of here. Now for the model setup, we have the name of the model. I've got a photograph of the model, and then in here I have all the different settings, but basically it's nothing more than just coming into the external module, Crossfire. I've got receiver number 4 and 16 channels, and then paging over, I don't have any helicopter settings or flight modes. And then in here we have our TAER. So this is throttle and yaw, pitch, and roll. So those first 4 are set up. And then arming. Here's the thing. We want to make sure that the next one, so this would be AUX 5. I'm not sure why I named it AUX 6. That should be AUX 5 or A5. I'm going to change that real quick. So I have that set up to where low. So when the switch is down, that's the lowest setting. Let me see if I can show you this. Okay, so you can see this. I don't know if you can see that little. Let me zoom in on the screen so you can see. And we go to arming here. Let me just show you that screen. So if you look right here, you can see that it's all the way to the bottom, all the way to the top, and at 2000 is arming. So my quad is armed, my quad is disarmed, and it's on channel 5. That needs to happen. You need whatever you got to do to figure that out. I have videos on how to change modes and everything. I don't really want to make this video much longer than it already is. So we'll go ahead and get out of here. And then other channels that you might have, let me back up a page because I've named them. So like modes, angle, horizon, whatever. I got a beeper set up for the quadcopter. Air mode, I run air mode on a switch. I don't have air mode enabled all the time. I think it's kind of a benefit to have it on a switch, to have muscle memory, so when you're flying through trees you can pull that air mode off and you can like hit branches and it doesn't go berserk, or you can land the quadcopter without dropping it down onto the ground. There's so many benefits, and I don't know if I should make a video on all the benefits, but turtle mode, pre-arm, I always have a pre-arm. I can't stress it enough. You know, you just pull this one switch up, boom, your quad's armed. Nah, no thanks. I like to fly in the winter. I'm wearing jackets. I got stuff that bumps into that switch, and that could happen. The throttle being up and that switch being pulled. What if my jacket runs the throttle down and pulls the switch up? So in my case, I have to pull this one up, then flip that one up. That's the only way to arm my quadcopters. So that's why I have a pre-arm. Some other stuff that I'm kind of messing around with. So that's the settings that you need to do. The other thing that we'll look at later, once we bind up the receiver, is telemetry. Right now there's no telemetry data. There's nothing in here. So we'll go ahead and discover new sensors once we get to that. And that's about it. The next step, after preparing our radio, let me zoom out for you here. So now that our radio is prepared and we're ready to go, the next step is to set up our external module. So we need to build some firmware, and we need to get that bin file created so that we can update this external module. So let's go ahead and shut the radio off here. And we'll jump over to the computer. Alright, so we're over at the computer. We're at Expresslrs configurator. This is a v1.4.2 configurator. So you want to kind of make sure you're using the most updated configurator when you download it. And in the configurator, we're going to have their newest release. So basically this is where I'm at this time and date. I'm not going to use pre-releases or nightly builds or any of that because I'm not a computer programmer. So, and then I have my device, so HappyModel 2.4 gigahertz device, and this is the external module, the HappyModel ES24 TX Pro series 24 gigahertz transmitter. And I am going to choose Wi-Fi. Download LUA Script, we've already done that, so that's completed, so we can move on. Standard mode, this is kind of all defaults here. Nothing really crazy going on. EU and then the rest of the world. And binding phrase. I'm going to use a binding phrase. I'm not going to show you my binding phrase, but you can type in anything you want in here, but you need to remember what it is. So once you flash this external module in your radio, that binding phrase is kind of set in there. So any receiver, when you update all your receivers, they'll have that same binding phrase. So that way when you power both devices at the same time, they will automatically bind up. It's ready to roll. And then if you have your radio turned off and you turn your quadcopter on, and or you're enabling the power or powering up your receiver, and you don't have your radio or your external module on, your receiver, in this case the EP1, is going to be looking for 60 seconds. It's going to look for the radio so it can bind up and fly. Well, if it doesn't see the radio, in 60 seconds it will automatically go into Wi-Fi mode, and then it will be ready to initiate updating and so on and so forth. My home Wi-Fi address and my home Wi-Fi password, so that my external module will automatically recognize the Wi-Fi. And here's the address that we'll look for once we have our external module powered up. We can find this address and go into the external module. So it's kind of like setting up a router or something in that situation. You can go in via your computer, via Wi-Fi, into your device. We'll click build. Everything here is done. There's lots of information on this on their website, and I'll show you that here in a minute. You can kind of read all these different things, what they mean, why you'd want to set them up that way. This video would be like 2 to 3 days if I went through all that. It's quite something. I mean, let me pull that information up real quick. So this is the website. This is just an amazing wealth of information, and this is how I've gathered all this information. I've read every single one of these tabs. I've read all these different highlighted subcategories, and it is an amazing amount of information. This would be equal in my mind to OpenTX University. So there's everything you can imagine, how to wire up your receiver, where it goes. I mean, this is everything you would need, and this is all the places that I went to make this video. So I'm trying to kind of summarize and make a comprehensive video to where you don't have to spend, I don't know, 3, 4, 5 days reading all this information. But if you need to know something, you can refer to this website. So Expresslrs.org 2.0 quick start receiver. So that's basically where I'm getting all my information. So let's go back to the configurator, and once we're done, I don't want to hit build in Flash. I want to build a file. This is going to create a bin file. When you click on build, you're going to get a status bar, and I'm going to tell you what, the first time you do it, it's going to take a minute. It's going to go through quite a bit of information. You'll see like a scrolling menu of all the things that's loading into this file. Once that file is completed, you'll have something that looks like this. This bin file is created. This is what you're going to use. So remember your location on your computer. If you put this on your desktop or you put it into a folder, whatever the case may be, you want to make sure that you have this ready to go. All right, so we're going to power up our radio.
Hey, Propsoff, when are you going to fly now? Switch warning.
All right, and we're going to go ahead and go into System. We're going to go into our Expresslrs LUA Script, and we are going to enable our Wi-Fi connectivity. Enable Wi-Fi, and you can see here that the device is the HappyModel ES24TX Pro. So we'll enable Wi-Fi. Enter Wi-Fi update. So we'll click OK. So now the Wi-Fi is running. You may want to have, some power cable. Make sure your battery's charged up all the way. The worst thing you can have is the battery die on your radio while you're doing this. So right now we have Wi-Fi enabled. I'll turn my screen off. I put my screen on so when I'm doing tutorials like this, it doesn't shut off. So I have it on a switch. So now we'll jump back over to the computer. All right, so now we're in our, we're at the computer, and we went to our Wi-Fi enabled device, and so now here we are in our module, and we can choose file. So this is the file that I had it placed in, and this is the file that we want. So we'll open that. And then here's the bin file that we're ready to go with. I've already done this, so I don't want to do it all over again, but you're just going to hit update, and there'll be a status bar that crawls across here. It'll turn green, say congratulations, whatever, and your external module will be updated. But like I said, before you start this update, before you hit that, make sure that your radio has the, make sure your battery's charged up. So go ahead and click update, and that will be done. Alright, once your status bar is completely filled up and it's successfully updated your external module, the next thing to do is to go into Betaflight with the Quadcopter. So let me go ahead and connect up Betaflight. I'm going to close all these programs out and all these files, and we will start fresh with just Betaflight screen. So let's go ahead and plug our Quadcopter in to the computer. Make sure you have a fan on your quadcopter. You wanna make sure that you have some air movement on your VTX. You don't want that thing getting blistering hot. So we have our COM port up. Go ahead and connect the Betaflight. Move our quadcopter around. Make sure it's moving around. If that's not moving, then you have problems. You don't want to continue. So we want to enable our serial port. So we're going to go to Ports tab and Uart 1. So in the when we soldered it up, that lengthy video of the hardware, we went ground 5V R1 T1. So that's the Uart that we want to choose. If you soldered your EP1 receiver to a different Uart, then you'll choose a different Uart. So serial RX, and we're going to choose Uart 1. And then I have Tramp. My VTX is Tramp. Use Smart Audio or Tramp. I soldered that to the T3 pad, so that's set up. So you're going to save and reboot. I don't need to save and reboot because I already did it. And we're going to come into configuration next. Let me grab my outline so I don't miss anything. Now we need to go in and we need to enable telemetry. So we're going to scroll down here and make sure that we have telemetry enabled. Like I said earlier, I don't have air mode permanently enabled, and that's something I might do a video on later. But so we have telemetry enabled, so we're going to go ahead and save and reboot. I don't need to do that. And now we'll go to Receivers tab. You're not going to have any stick movements at this time because we haven't updated our receiver or initiated any of the firmware. But in here, we just want to set everything up. So right now, our R-xsr is S-bus. We want to change that protocol to Crossfire. Serial Uart is correct. Serial-based receiver, basically. But we want to go Crossfire. And we'll go ahead and save and reboot. The other thing we want to do, I know a lot of videos out there had missed this point. If you go to PID tuning, you want to come up here to jitter reduction. And if you read this, the default is 7. Higher values 10 and 12 are good for cinematic or HD freestyle. So you got like 10 to 12 jitter reduction. But if you're racing, and in my case, I've got this on my super duper mega ultralight 138G 4S 5-inch or V2.2. I can't help myself. So I want this thing to move as fast as possible. I'm flying very close to myself. I'm not doing long range. I'm not doing cinema. I'm ripping. I want this thing to heat the motors up and have a lot of fun, right? So I'm going to go ahead and run that down to 5. 5 is good for racing and really fast link. So I'm going to change that to 5. And then smoothness. Here's something that's really interesting. If you look here, that's hard for me to do both, but if you look right in here, the default value is 25, and that's good for 50 to 100 hertz packet rate. I'm going to run 500 hertz packet rate, so I'm going to run maxed out. But if you're running like a QX7 or you're running an older radio, you're not able to run that high of baud rate, 400K or higher. You might want to run a little bit less. So maybe 25 is good for 150 hertz. For 250 hertz, you might want to do 40 or 50. I'm going to do 65 on the smoothness because I'm going to run the 500 packet rate. So I'm going to go ahead and save that. And now we need to go to CLI and check a couple parameters. Right now, if you go into CLI and just type in get serial RX, so this will give you all the information. So that's the changes we just made, this Crossfire. And then right here we inverted, and then the half duplex. So for the EP1 Expresslrs receiver, we need to turn the serial RX inverted to off, so it's already off. You can see here loud values on and off. Serial RX inverted off, so that's good. And then the half duplex, we want that off. So if either one of these are on, you need to change it. I guess I'll show you real quick. If you it's real easy if you just copy that and you stick it in here, and then you hit paste, and then just put set. So set serial RX inverted to off, and then you know, like in your case it would say on, but you just change that to off, and then hit enter. See, now I just changed it to on, so now I got to change it back to off. So I'm going to set space serial RX inverted off, and then just type in save. So we're done in CLI, and we are done in Betaflight. So our quadcopter, our flight controller, is ready to go. Our next step is to flash and bind up our EP1 receiver. So let's go ahead and jump back to the bench. All right, so we're back over to the bench here. We're just going to move the radio out of the way. We got our quadcopter here, and I have a USB port connect to the computer. I wanted to just show you the receiver. You can see the green flashing light right there. The slow flashing light on the receiver is means that it's powered up, and the slow blinking is meaning that it's enabled. Now if we wait 60 seconds, I think it's default. We haven't changed anything in the receiver itself. I have my radio off, so we're just waiting here. There, you see that? See how it's rapid flashing? Rapid flashing is letting us know that it has went into Wi-Fi mode. So I just wanted to show you that real quick. So the rapid blinking is past the interval, and then our case, we're going to set this up for 60 seconds instead of how long that was. I had to edit some time out because it took a little while. I can't remember what the default is. But that will happen if your radio's off. Your receiver will go into Wi-Fi mode after a certain interval, and we're going to set that up to 60 seconds. So let's jump back over to the computer. We're going to go ahead and unplug this. We don't need this on anymore. And we'll jump back over to the computer, and we'll get all the information that we need to update this receiver and to add all that information, and then the binding phrase and all that stuff is just all magically going to work. So let's jump over to the computer here. All right, so we're back over to the computer here. We're at Expresslrs configurator. Make sure that you go to your Wi-Fi and enable your Wi-Fi to your home network, because we were Wi-Fi connected to our external module on the radio. So now we're connected back to the worldwide internet, and we have this information pulled up. Again, we're using the same release candidate, and our target is going to be HappyModel 2.4 gigahertz, HappyModel 2.4 gigahertz, and the device this time, instead of using the Pro, we're going to be using the receiver, so that we're using an EP1 24 gigahertz receiver. So this is ready to go, and I am going to use Wi-Fi. You can use Betaflight pass-through, so you can plug in your quadcopter and run it through the Betaflight, but I'm going to choose to use the Wi-Fi because I think it's pretty easy. And standard mode, everything's set up here in default, so you have EU or the rest of the world. Binding phrase needs to be the same, and you need to remember what that binding phrase is for other receivers that you may put in place. And then we changed that to 60 seconds, so we kind of went through all this stuff already. The only thing we really needed to change is just these options here in the Wi-Fi. So we're ready to go, and we're going to build the file for our device. I'm going to edit and zip on through this. It will create a folder for us. Alright, once the configurator was done building the file, so the bin file's been created, and I moved that file to a folder so I know where it is. So here is the information here. So you can see here there's a little bit of a difference. So that has changed from our external module. So now this is the bin file for our receiver. So now we need to go ahead and plug in our quadcopter and power up our receiver and let it go into Wi-Fi. So that rapid firing LED light, we need to allow that LED to go into a rapid situation so the Wi-Fi will come on, and then we can find that Wi-Fi. So I'm going to go ahead and plug the quadcopter in, and I'm going to put a fan on it. Alright, we're going to go ahead and grab our Wi-Fi. Once we enable the Wi-Fi connection between the computer and our receiver, the receiver's rapid fire blasting. Sorry I have a fan on because I do not want my VTX to burn up while we're doing this. So I have the HappyModel right here. You can see the HappyModel EP24. So this is 24 gigahertz receiver. So we are on the correct one. Our radio's turned off. We can go in here and choose file. In the file here, I put the receiver information here. So we're going to choose this file. We're going to go ahead and open it. And now it's open. We'll go ahead and hit update. All that scenario. So go ahead and update the receiver. And while the receiver is being updated, the LED went off. And now that it's completed, it's a slow blinking LED. So we'll hit OK. And we're done with the computer. So let's go ahead and jump back over to the bench. We have our quadcopter on the bench here. I've got a LiPo ready to go. I have my props removed. Please don't do any of this with your props on. More and more stories coming up. It makes me wonder. So I have my props taken off. I'm ready to go. So before I power up this quadcopter, I'm going to go ahead and power up my radio.
Hey, Propsoff. What are you gonna fly now?
We have the correct model chosen. All right, so our radio's powered up. Our external module's powered up. You can see that LED is turned on, ready to go. So everything's ready to go on the radio side. We're going to go ahead and plug in the quadcopter. We can see the LED on here is solid green. So we can test it. So I have a... Okay. And then simply, if you just go into your model and page back, go to Discover Sensor. So now you can see all the telemetry data in here. Let's see if I can not roll that so fast. But you can see all the information you could ever want. Go ahead and hit stop. And then the one thing that's interesting right here is the RxBat 3.8. So my LiPo is at storage charge, and 3.8 is a correct number. So if I have a meter in here, I can test to make sure. But it's kind of cool to have that in the special functions. I'm just going to show you this real quick. So if I were to pull up my SH switch, that's kind of my go-to switch. I use it for a lot of stuff. So that's what we want to use. So we'll go ahead and return. Oops. SH switch, enable it, and then function. I want to hear a value, so we want a play value, and then we go here. We can go to RX, so we can go to BAT. There's an easier way of doing this. So right here, BAT, and then I just want it to say it one time. So go ahead and return. So now when let me turn my volume up. I put my volume. Let me pull this down so you can see what I'm doing. I have my volume on a pod.
3.8 volts.
So it'll play the voltage of the telemetry that it's receiving. So now we need to do some fail safe. So what I'm going to do is I'm going to go ahead and arm the quadcopter. Let me focus in on here for you. Of course, we don't want to have this on too long without some air movement on that VTX. I do have the VTX turned down to 25 milliwatt while we're doing this. If you can, put it in pit mode. Go ahead and arm the quadcopter. Alright, so the quadcopter is not wanting to arm. So let's go into Betaflight and see why. Alright, we'll go ahead and connect up here, and we're going to go to setup. And right here, we have a no pre-arm, MS, and an RPM filter. So let's go over here to Motors tab. Why is the RPM filtering? Bidirectional D-shot, RPM filtering. Alright. And we'll go to setup again. Without the LiPo plugged in, the ESCs weren't communicating the bidirectional D-shot. No pre-arm and MS. So let's go to the modes tab here and see what's going on. So if I pull up on pre-arm, you can see flip over when crash is going. So it looks like we have a couple different things going on. So that's not supposed to do that. You can see right here, this flip over when crash, when I pull my pre-arm switch, that's going off. So let's go ahead and get pre-arm on the correct switch. So go to auto. So aux4, I need to get a fan on this quadcopter. Alright, so I know that fan's annoying, but if you put auto and then flip your switch, so now pre-arm, when I pull up on pre-arm, let me save that real quick. So now you can see that it comes up for pre-arm, but flip over and crash is on the wrong switch. So we'll go ahead and change him. So this is the correct switch. So when I have turtle mode on, it'll be right here. Let me go ahead and save that. And then when I have turtle mode off, it goes down. Now air mode is on the wrong switch. So let's go ahead and choose that. So air mode is on all the time when I'm flying, and then when I want to turn it off, I pull the switch. Let me go ahead and save that so it works for you. So now it's working. So air mode is on all the time until I pull the switch. Beeper, that's on the wrong switch too, so let's go ahead and switch that up. Alright, so now we're on the correct aux channel. Horizon angle, so that's correct. Arming is on aux1, so that's channel 5. We want to make sure that, and then you notice here when I go to arm the quadcopter, it goes up to 2000. You can flip the switches in here, but you want to make sure that disarmed is at 1000 and armed is at 2000. Let's go ahead and save that. So we should be good to go now. That was the issue. So we'll go to setup here. Pre-arm, I can pull the switch. You can see that it just went away, so my arming flags. So if I let go of pre-arm, now it's not going to arm because of pre-arm. This MSP is always on when you have it plugged in. When you're plugged into Betaflight or you're plugged into the computer, the Betaflight devs have set up a fail-safe issue so that you cannot arm your quadcopter while it's plugged into your USB port. Of course, there's ways around this, and I'm not going to show you how. So we're done in Betaflight. Let's go back to the bench. So go ahead and plug the quadcopter back in.
Telemetry recovered.
Alright, and then now we're just gonna check. So there's our beeper. So, and then our modes. Need to turn this off because this is also turtle mode, so I need to turn my screen off. I just do that for tutorials. So if I pull my pre-arm, pull my arming switch up, okay, we got juice. See, if I pull the arming up, nothing's gonna happen. I have to pull. See, I just went into failsafe. I have to pull my pre-arm up, then I can arm. There's air mode. There's switches. Let's check flip over when crash. So go ahead and arm it. And then very lightly. Turtle mode is pretty gnarly. Alright, so we're good on turtle mode. So we'll go ahead and disarm. Now, we need to do some pre-flight checks. So I'm like super excited, okay? We've done it. we've went through the process. We've got the receiver, the external module, all that on the same firmware. We got the binding phrase, so it automatically, we didn't have to do nothing. You just power them up and it bound up. So everything is hunky-dory. But we need to do some pre-flight checks. Do a couple things. And first thing we want to do is get our quadcopter plugged in. We have our radio on. I'm going to go ahead and arm the quadcopter. If you have air mode on all the time, see, I have air mode on a switch, okay? And then I also have motor stop enabled because I don't want my motors to spinning with air mode. It's just such a pain. I like to have it on a switch. So that's why things may be a little different. I prefer it this way. So the motor stop off. So we're going to go ahead and just throttle the motors up. Go ahead and shut it down. Boom. Right away, the quadcopter is going to go into a fail-safe, and in default, set up in Betaflight, it's set to drop. So if anything happens to the communication between this radio and that quadcopter, whether this thing is, gotten behind something or whatever the case may be, this thing's going to drop to the ground and it's just going to go into a failsafe. If you have like GPS rescue or something set up, the failsafe would initiate. The quadcopter is going to go to a certain altitude and fly its way back to home base. I don't mess with that kind of thing. I fly under trees and way too sketchy stuff to have this thing autonomously do its thing. So it's set the failsafe to drop, and that worked out well. All right, so I got the top plate on, and kind of our last step for the pre-flight is to make sure that our link quality and our RSSI is doing its job to make sure that we don't lose the radio link to our receiver. And so the next step is to go ahead and look at that information. I have my radio on. I'm going to go ahead and slide him up out of the way. I'm going to plug in this LiPo, and I have a fan off in the distance, and I have a monitor for you to see what's going on inside. Turn on my fan, plug in the quad, and set this off into the distance here. So I have my lens cap on so you can see the data instead of, stuff in the background. So let me go ahead and adjust the lighting. All right, so over here in the corner, I have everything kind of set up. I have what mode I'm in, my VTX channel, my average cell. So I'm running four cell battery, so the average cell. You can see that this is getting down to where it needs charged back up. I have my pilot name, and I have how many minutes the quad has been armed. And then you'll notice here, these two things are a little different. So with the R-xsr, you would just have RSSI value. So you'd basically just have the little scale, and it would be like 99 or 100. And then as you flew out away, it would drop down. And if you got to like 30, you'd fail safe. 32, whatever the case may be. But in this case, with the ELRS, we're having two different factors in here. We have link quality, and then we have RSSI decibel. So without making this video another hour longer, I'll try to summarize this real quick, and then we'll jump over to the computer and show you how to set that up. So link quality is how many packets. So every movement that I make on the transmitter, so every stick movement, every thing that I'm doing, it's sending packets out. And in my case, it's 500 packets a second coming out. And so how many of those packets are being received in the quadcopter? Right now, 100 are. There's 100%. So I'm getting all 500 packet rate. Now, as I let's say I take the radio and I cover up the antenna, I kind of hide it best I can. This thing is pretty amazing. It's still saying it's getting 100 packets or 99% of the packets. So as you can imagine, once this gets to about 50%, you can still fly. The link quality, you're still good at 50%. But I want to know, like I really don't want half of the commands. I want very smooth movements. That's why I've purchased this system. That's why I'm investing in it and doing this video to help out the 4 or 5 people that have kind of really wanted me to do this for them. So anyway, once this gets to 50%, then imagine that out of the 500 packets, I'm only getting 250 packets. So I'm only getting half. And as that percentage of link quality drops, I'm losing more and more packets. So I'm losing more and more data as I'm making quick movements. And in racing, this really makes a big difference. You know, if you're just doing cinema long range, you know, you might get down to like 20% or 30%. I think 20 is a little bit too low. But, you know, it could get really low, and the packets are just, you know, the quadcopter is just making little movements. Okay, so link quality is how much of the packets being sent from the transmitter is the receiver actually, you know, grabbing a hold of. Now, RSSI, in this case, the decibel is a negative number. Okay, and you know, with our RxsR and our Frsky garbage, we just thought, you know, 100% good, 30% bad. But in this case, the negative number, so like a negative 27 is much better than negative 90. So negative 90, you're kind of getting to the threshold. There's actually a mathematical table in the website for ELRS. I think it's negative 105 is the limit. You know, the RSSI limit. So imagine RSSI at, let's say there's just a tunnel. There's a tunnel, and that tunnel's full of garbage. So other signals, other pilots around you using up bandwidth. Everybody's got their radios on. They're all, you know, blasting as hard as they can. That value is going to go up to like negative, you know, 90, and you're going to be having a hard time keeping the radio link, you know, together. And as soon as this number goes too far to the positive, you fail safe. So that tunnel of garbage, you can imagine that the push or the power that you're outputting from your radio isn't getting to your receiver because of all the stuff in its way. So that number is just going to increase, and once it gets to negative, I think it's 105 per the website, you're going to fail safe. You're going to have issues. So we want to keep an eye on that. But we need to set these up in Betaflight, and there's a couple other things that we need to do in there to make sure that this comes up on the screen and works properly, and you get notified. So right in here, you'll have like a flash warning, low RSSI or low link quality. You want to be able to you know, have that information so you're not just fail-safing out of the air because you're getting lower and lower as you fly away. I can cover up this antenna and kind of bury this real good, and you can see that I'm causing interference, or I'm causing trash or blockage from the RSSI. Obviously negative 50 is awesome. You're going to have absolutely no issue with these numbers. But as you get further away and there's more garbage in the way, there's more trees, especially if it's really moist. You know, if it's a heavy dew morning when you're out flying, you go behind a tree, it's like a brick wall. So this number is going to increase towards the positive, and it's going to get worse and worse. So right now I have my radio set up for 100 milliwatts. That's what I plan on flying. I don't fly very far for myself. I like to listen to my quad rip around, and I'm usually really close to myself. Obviously, you can increase your milliwatts above 100 milliwatts with this external receiver. It goes quite far, and you're going to push your tunnel is going to have more force to get through that garbage. So that number is going to stay a little bit more on the lower negative side. I hope I explained that as quick as I possibly could without making this video, like I said, another hour. So let's jump over to Betaflight, and we're just going to check all those parameters, make sure that all that's set up correctly, and we'll get that done. I love it. Alright, so we're over here at the computer, and just to show you real quick, so the information is all in here for your Expresslrs. So, you know, I'm not just kind of making things up. There's all kinds of stuff to read here, and then there's like a threshold table, so 500 hertz, 0.0105 decibel. So this is kind of a fail-safe, you know, issue. So you're kind of wanting them to be in that negative 20 to 90, if you will. So we need to go to Betaflight and get this stuff set up. So let's go ahead and connect up. I have a fan on my quadcopter while we do this. So we're all plugged in here. The first thing we need to do is go to receiver, and we need to disable the RSSI channel. So as you know, with the Frsky receivers, we're going to have like this on channel 8 or channel 12 or something like that. We need to disable it for this protocol to work, because 11 and 12 is your link quality and your RSSI values. So go ahead and disable RSSI channel and hit save. And then we're going to go over to our OSD, and we're going to enable a couple things in here. So we're going to enable our link quality and our RSSI value. Okay, we can actually get rid of this. So link quality RssIdbm value. So that's going to give our two numbers here that I was showing you on the monitor, and you can place them anywhere you want on your screen. And then here we want warnings, so we do want a RSSI and our link quality and our RSSI decibel dBm. So we want to enable the alarms, and then RSSI threshold at 20, and I think that's pretty much everything. Post flight, you can, if you want, like when you unplug or disarm your quad, there'll be like a big list of all kinds of stuff here, and you can have all these different things put in there. So I don't really care about current draw, because this quadcopter has a terrible ESC or PDB on it, and it doesn't do a very accurate job. It doesn't have any black box, so I can get rid of that. The voltage, battery voltage, I guess it'd be nice to have some of that information come up. And then I don't have any of this. I don't have any GPS, so I can't tell distance, link quality, RSSI, that kind of information I like to have. Can't do anything with speed. And then timer 2 is the how long you've been armed. You can have also how long has the quadcopter been plugged in. So how long has the flight controller been powered? How long has it been armed? So those are kind of good things to have. So that's about it. And I know that this camera is PAL for sure. So I'm going to go ahead and change that to PAL. If you know what camera you got, put it on there. Auto is okay, but sometimes it causes issue. Or sometimes you can't see your OSD information because one of these two are incorrect, or it's on auto and you need to have it on the correct one. So we're going to save that. Alright, so that's all set up. Now the last thing that we need to do is go over to our radio and change our telemetry limits. So 50/20 is what was recommended through some information that I've gathered. So we'll jump over back to the bench and get that set. So everything's done in here as far as I know. Should be all good to go. Alright, so we're back at the bench here, and we just want to go into our model. So we'll go into our model, we'll back page one time, and we're going to go to our telemetry page. And in this telemetry page, you have all this data that's coming back from the receiver. Now I'm unplugged, so this information isn't changing, as we speak. It's kind of frozen in time. But basically, you could set up all kinds of things, and this radio could literally yell at you the entire time you fly if you want. So I just have like average cell voltage. So that's it for me. But the ELRS devs have said that the low alarm, critical alarm 50/20 is what you want to set up as. That's kind of that's the one that's going to get you through it and take care of. So that's kind of where we're at. I think, this video has taken several days to film and a large amount of editing. I hope that this is something that really has helped you get along. I tried to make it in a flow the best I could with an outline. I'll try to put that outline in the description with time frames. I'm not sure how much work I'm going to add to this video later. If you have any comments or you've seen something throughout this massive process that I've just gone through, let me know in comments. Things that are critical, need to know for sure. I'm going to pin. I may end up doing a follow-up video. I just really don't want this video to be a 3-hour video. There's a lot of information out there, but as you can see from this process, once you do it, once you kind of see it done and it makes sense and it's kind of explained in such a elementary way, then the next time, it's just so easy. It's so quick. You just wire the thing up, bang, bang, bang. If your module's already done, you just throw it on the internet, boom, load up the firmware, it automatically binds and you go fly. It really does make a lot of sense. Now, because it's taken days to film this, I've already flown this. I know, don't get mad at me, but I've already taken this out for a rip, and I'm going to tell you right now, the hype is real. I really thought that this whole ELRS thing was just, whatever. Yeah. Okay, guys, super excited about the new thing. But, as mature as it's gotten to be, it's really something else. I mean, you can move that stick just ever so slight, and the quad is I don't know how to explain it. I don't want to dog Frsky too much, but that R-xsr that was in there was, a new R-xsr. This is a pretty much new build. This is my V2.2, and this thing has such a smooth movement. I mean, the controls are like instantaneous. I'm not having to predict, like when I, go through something, I don't have to predict that movement, add that stick before it gets there. It's literally on top of it. Like as I'm moving the sticks, it's doing exactly. It's hard to explain. But I'm not gonna jump on the hype train too much, but I'm there. I'm really surprised about how well this flew. So before I get into any more, I'll get some flight footage of this eventually. Doing the flight footage thing really takes up a lot of my hobby time, and I don't have that much. So I'll try to get something out. Hey, you know what? If this video helped you out and entertained you in any way, give me a thumbs up, subscribe. If you hated it, man, you give me a thumbs down. It all works. Enjoy the breeze.